Now we're going to talk about container types in Python, beginning with lists. Containers, or data structures, are operands, meaning they can serve as inputs of operations. They're operands that contain other operands. Python provides multiple types of containers, and they differ from each other in the way that they organize the objects they can contain, which are called their elements, and the operations for which they can serve as operand. Lists are containers that organize elements in a sequence, like a row or a column in Excel. The interpreter identifies lists by their delimiters, which are square brackets, and each element is separated by a comma. A list looks like this in Python, and in syntactic terms, this thing that I've written right here is called a list display. I'm assigning this to the variable name list A. I'm printing list A, so it will be displayed as an output, and then I'm also printing the type of list A. When I execute this cell, I can see a list display output from my cell, and the type function tells me that this is a list. Lists can contain objects of any type, including other lists. The interpreter will first evaluate an expression in a list display and then store its result in a list. So if you put something like this in a list display, here I'm calculating the absolute value of 10 minus 50. This expression itself will not be stored in the list. The interpreter will say 10 minus 50 is equal to negative 40. The absolute value of negative 40 is 40, and then it will store that result in the list. Other than that, I am putting an integer, a float, a boolean, a string, and another list inside this example list. When I execute this cell, I see exactly the same objects that I put in my list display, except here I have the result of my absolute value function. Each element of a list is associated with an index number beginning with 0. In this simple list, ABC list, I have 3 letters. A would be associated with index 0, B with index 1, C with index 2. That's useful because we don't just want to store objects in lists, we want to do things with them, and that requires us to reference them. You can access a single element of a list through an operation called subscription, which is also called indexing. The operation of subscription is initiated by a syntactic pattern, which is called by the same name. What I mean by that is, syntactically speaking, this thing that I've written right here is called a subscription, and it triggers an operation called subscription. So when I execute the cell, I just performed subscription with a subscription. And the syntax of a subscription is, first I write the name of the list, then I add a pair of square brackets, and inside of those square brackets, I put the index of the element that I want to refer to. If I write a subscription containing an index that does not correspond to a list element, remember ABC list only contains 3 letters, index 5 would refer to the 6th element of that list, which doesn't exist. If I execute this cell, the interpreter tells me that this index is out of range. The interpreter evaluates bracketed expressions before it evaluates subscriptions, which means that you can use an expression in a subscription as long as the expression results in a valid index. Here I have negative 4 plus 6, which equals positive 2. I do have a third element in ABC list, which would be associated with the index 2. So when I execute this cell, I get that third element, C. In addition to subscription, you can extract multiple consecutive elements from a list through an operation called slicing. And like subscription, the operation of slicing is initiated by a syntactic pattern, which is called by the same name. This thing that I've written here in syntactic terms is called a slicing, and when I execute this cell, I have performed a slicing. In its most basic form, a slicing contains a start index, the 0 that you see right here, and an end index separated by a colon. The interpreter includes the element associated with the start index, but excludes the element associated with the end index. Unlike subscription, which can return an object of any type, depending on what the object is that's associated with the index that you give the subscription, slicing a list always produces another list. Here I'm writing a subscription that points to the first element of ABC list, and then I'm checking the type of the object returned by that subscription. Down here, I'm slicing ABC list, and I'm checking the type of that slice. When I execute this cell, I see that my subscription returns a string, that letter A, but my slicing returns a list, even though that list contains strings. When a slice involves the first or last element in a list, the associated index can be omitted. If I omit the start index in this slice right here, then the slice begins with the first element. Here I've put no index, a colon, and then the index 2. So I get the first element, the second element, but not the third, which is associated with index 2, because the interpreter excludes the element associated with the ending index. In this slicing, I'm beginning with index 1, which would be the second element, B, and I've omitted the end index, which tells the interpreter to end the slice with the last element of the list, and that's what happens down here. A slicing without a beginning or an ending index will return the whole list that you're slicing. If I omit both the start and the end index, I get the whole list that I started with. By default, like we've seen above, a slicing will return an uninterrupted series of consecutive elements. But you can skip elements by adding a step value after the second index in a slicing. For example, I've created a list called numbers here with the integers 1 through 8, and the indices associated with those numbers are written below. Now I'm creating a new list called even numbers, and to get that, I'm slicing my original numbers list, beginning with the start index of 1, and then an end index of 8, and that would be associated with the 9th element if there were one. After my end index, I'm adding another colon followed by my step value, which in this case tells the interpreter to give me every other element beginning with the index 1. When I execute this cell, I get 2, 4, 6, and 8. So the second element of my numbers list is 2. Because I've included a step value of 2, the interpreter skips 3 and then gives me 4, skips 5 and then gives me 6, skips 7 and then gives me 8. And that's what I have in this slice that is returned to me. And if I wanted to, I could exclude this ending index and I would get the same result. Also, as a small quirk of lists, you can't refer to an index that is out of range in a subscription, but you can refer to an index that's out of range in a slicing. So I could tell the interpreter to end the slicing at index 100, and it'll give me the same thing. However, if I write a subscription with the index 100, I'll get an index error. In addition to positive indices, each element in a list is also associated with a negative index. You can use negative indices to reference elements based on their distance from the end of the list. In this case, my last element, C, is associated with index -1, B with -2, A with -3. And so if I write a subscription with index -1, I get C. I can use a negative index in a slicing, like in this case, and I'll get B and C. You can change an element of a list by targeting the associated index in an assignment statement. So here I'm creating a test list containing the elements 1, 1, and 3. I'm gonna display that so that we can see what we're starting with. Here I've written an assignment statement. The target of my assignment statement is a subscription, including the index of the element that I want to change. I want to change this second 1 to a 2. So when I print that, you can see that the second element has changed from a 1 to a 2. This is the syntax that you use to make that change. If you attempt to assign an object to an index beyond the range of a list, the interpreter will raise an index error. So this is not the right way to add a new element to a list. Python includes a list method that we'll talk about in a later video to do that job. Like with strings, the plus and asterisk symbols initiate concatenation and repetition when they receive lists as arguments. So if I create list B and try to add that to list A that I've created earlier, then I see list A, 1, 2, 3, followed by list B, 4, 5, 6, combined together in one single list. If I attempt to multiply list A by 2, it is not multiplied but repeated. The len function returns the length of a list, which can be useful if you want to know how many elements are inside. The in keyword tests for membership, so I can check, is the integer 5 a element of list B? Yes, it is. Finally, Python includes the list function, which allows you to convert compatible objects into a list, such as this string XYZ. If I pass it to the list function, then each of these characters is made into an element in a new list. That's it for lists. If you like this video, please give it a like. And if you want to see more, subscribe, and I'll see you in the next video.